Where's our musician? Dave.
Who's doing that? Okay. So I think we're ready to go whenever we have a quorum.
Okay. We'll wait a couple of minutes and then we will get started. For everybody that's already online, we'll start in 2 minutes.
Yeah.
Perfect.
We're all bopping. Well, you know, we decided that it would be good to have some kind of music because sometimes when you're sitting here and you're waiting for all the people to sort of, you know, filter in, it's a little awkward. Everyone's just kind of sitting here and
Staring at each other.
Just so, as long as we don't discuss each other's hairstyles.
yeah. Everyone's hairstyle is long. That's what I.
Right, exactly.
Except for the guys, where like it's easier to just kind of cut their hair. You know, for us, it's like just going to be long.
I feel like camping outside of my hair salon, waiting for the minute that they open. I can be first in line.
There'll be fights. Who gets to go first?
I think I was at least 5 the last time I've tried to cut my own hair. It didn't go well.
You're going to have to definitely make sure that, you know, that person has all the proper PPE.
Yeah. They probably won't open before they have.
Yeah.
The last time I cut my hair, I was about 5 or 6. It did not go well.
Did it amuse your mom?
Mm-hmm. It even amused me. I cut and my bangs were still too short.
Yeah, I made the mistake of like pulling it down and cutting it, and then when it jumps back up, it's like way shorter than you thought it was going to be. That's, you know, many years ago.
I thought that was just last year, Anita.
As you've ever seen me with bangs.
All right.
Okay, it's 3 minutes past 2. So we're going to officially start office hours with Anita and Dave. It is June 2nd, just in case you didn't know, in 2021. Just checking if you're awake, 2020.
You get to hear it.
So today we're going to focus all about sustainability, and we're going to discuss the progress we've made at the UC Davis Teaching and Research Winery and the Jess Jackson Sustainability Winery building in becoming water positive, electricity positive, as well as carbon neutral. We're basically going to talk about work that's being done here, focusing on generating renewable energy, collecting rainwater for processing and recycling, achieving carbon neutrality by capturing the carbon dioxide from fermentation and reusing and sequestering it. To address these topics, we have 4 speakers today. We have Joel Brigham, Ned Spang, Runnebaum, and David Block. And I'm going to give a very brief introduction for each of the speakers. So in no specific order, it's just what I have on my paper. We'll start with Edward Spang. Edward, or Ned, is a professor in food science and technology, and he's the faculty lead for the Food Loss and Waste Collaborative. We have Joel Brigham. She's the executive director of the Sustainable Wine and Food Processing Center. And just because it's cool to say, she joined us from NASA's Johnson Space Center. I love to say that I know somebody that worked at NASA. We have David Block. He's the professor at Viticulture and Enology. He's also the current chair for the Department of Viticulture and Enology. He's also a professor in the Department of Chemical Engineering. Very similar, Professor Runnebaum is also a professor at the Department of Viticulture and Enology, as well as at the Department of Chemical Engineering and Material Science. So with that said, I'm going to throw the ball, so to speak, to David Block, as he's going to start the introduction of today's section.
All right, thanks, Anita. So as Anita said, today we're going to focus on sustainable wine processing. And I wish I could say it's anybody's fault but my own, and Ron even mentioned this and never corrected it. On the title slide that you're seeing there, I've listed as Viticulture, Enology, and Food Science, but actually Viticulture, Enology, and Chemical Engineering. My own mistake. So when we're talking about sustainable wine processing, obviously there are a lot of wineries out there that are interested. Obviously you're interested, that's why you're here. Our department became very interested in this a number of years ago, and started with mainly, the main push started with our LEED Platinum certified teaching and research winery, which is the most sustainable winery in the world. And that was really an achievement. And Jill, you can stay right there if you want on that slide, and I'll pass it over to you.
Okay.
But that winery opened up in 2010, still running. It's at capacity. It's over time has become more sustainable than it was when it opened. And after it opened, we really had the vision of taking the most sustainable winery in the world and taking it off the grid for both energy and water, and capturing all the carbon dioxide that was produced in the winery. And so that was a goal. The main push towards that goal came with the Jess Jackson Sustainable Winery Building, which was a gift from Jess Jackson before he passed away, and Barbara Banke. And that vision was to give us a place to achieve our goals of being off the grid for energy and water and capturing all our carbon dioxide. Around the same time, we along with Food Science, started the Sustainable Wine and Food Processing Center. We hired Jill Brigham to be the executive director of that, given her expertise in project management and self-sustainable systems at NASA, and look to further that vision, to really accomplish the vision that Jill will be talking about in just a minute. So all that we've done is through a series of generous gifts from the Jackson family and other companies, as well as a series of research grants from various private and governmental agencies to try and achieve that goal. And I think we've made terrific progress. That's what Jill and others are going to focus on today. We made terrific progress. We're not quite there yet to our goal. We'll talk about where we are exactly, but we made a lot of progress on the things that we originally envisioned. But we've also made progress on things that we didn't originally envision, but we're able to work on now because the facilities in the Robert Mondavi Institute and the winery and the Jackson building and so forth. And so we're going to talk today. I'm going to turn it over to Jill to talk about our goals and where we are in meeting them, and what things we're doing now that were never even envisioned about 7 years ago, and defining the cutting edge of sustainability in wine processing.
You want to tell people how they can ask questions?
Yes. So what we're going to do is we'll be doing a presentation for about 15 or 20 minutes. If you have questions along the way or after that, you can hit in the participants panel, you can hit the raise hand button, or you can actually message Karen or to everybody and have Karen or Anita read the questions. Whatever works for you. You can unmute and interrupt us if you need to. That's fine as well. So with that, I'm going to turn it over to Jill to start talking about where we are on defining the cutting edge of sustainability in wine processing.
Great. Well, thank you, Dave. So yes, today I want to talk about what we've accomplished in sustainability and how we've done that. And both with Ron and Ned will tell you about some of the projects that we've been working on. Many or most of these projects have been made possible thanks to the Jess Jackson Sustainable Winery building. It is a building that has 10 open, very flexible bays in which we our goals are to fill those bays with systems that will enable us to reduce the amount of water and energy that we use, and to sequester our carbon dioxide that's produced during fermentations. So we've had for quite some time, working with Professor Roger Bolton, we've had ideas for what we want to do in the Jess Jackson building to enable us to be energy positive and water positive in the winery. And so the Jackson building functions as a space for prototyping and trialing these new systems to support the winery, to be able to measure and improve our systems. And it's very open and flexible so that we can remove and replace systems at will, in a convenient manner. So we have made some good progress here. You can see that these are the systems that we had pretty much originally envisioned for the Jackson building, and it comes under the themes of water. We have reverse osmosis and processed water nanofiltration, water storage, hot and cold water, and then also energy in the form of solar and battery storage, and potentially in the future hydrogen-driven fuel cells. But other systems and processes are also possible. As Dave said, we never really envisioned having battery energy storage, but that came along technically and became much more feasible than the hydrogen system, that we just couldn't have seen that 10 years ago. So we'll tell you a little bit about these systems and how our progress is going and where we are with each individual system. So one of the questions is, why is sustainability important to the wine industry? And other than just being a good steward of the environment and using less energy and less water, sustainability really enables us to be more resilient and to be able to handle disruptions and changes that occur in our professional lives. And I think we here in California have seen that, certainly in terms of issues like we want to be ready when we're in fire season and PG&E shuts off our energy source right during the middle of harvest season. Or we want to be able to reduce the amount of groundwater that we're using so that we don't worry about running our aquifer dry in the middle of harvest. So this takes planning and investment, and this is the kind of work that we're doing to enable the industry to be more resilient and as well as to be good stewards. So from an energy standpoint, our goal is to become energy positive, to be able to generate more energy on site and to be able to reduce our peak energy demand. So be able to reduce the maximum amount of load that we would have on the system. And that's important because that's what we get charged for. And I'll get into that in a little bit more soon. But your winery is charged on a commercial scale during peak hours, a significant amount of dollars per kilowatt hour, probably in the late afternoon, early evening than at other times of the day. Well, that's also when all of your air conditioning systems are on, and it becomes much more, your loads rise, and it becomes much more expensive for you to operate your systems. So we want to reduce our total energy use and also be able to reduce our peak demand as well. So we have installed 200 kilowatts of solar photovoltaic panels on the winery, the brewery and food processing plant, and just recently on the Jackson building. So we have a total of 200 kilowatts of solar voltaic panels. The Jackson building systems were made possible through a recent California Energy Commission grant, which provided the solar panels on the Jackson building, as well as the battery energy storage. So we have, as part of our solar panels, we need to be able to store that energy that's produced and be able to use it later on. And so to be energy positive, we have used the batteries that are from Nissan Leaf cars. So we're provided free of charge Nissan Leaf battery packs, as you see here, and we've repackaged them and have constructed 2 strings of batteries. Look like this, 260 kilowatt hours of batteries that we charge using solar energy in the daytime and then discharge as needed, typically, as I said, during those peak charge hours. In PG&E territory, that's typically between 4 p.m. and 9 p.m. So you can see here we've got 2 strings of batteries and all the control electronics and inverter here. And it's all nicely packaged here in this 20-foot shipping container, which is right out behind the Jackson building. So those batteries are charged during the day by solar panels. And you can see that here in this chart shows 3 days of energy charge and use by the building. So if you look at this chart, the aqua color line is the solar energy that we're bringing in through the solar panels, and we're using that energy to, in the middle of the day, to charge our batteries. And then once the batteries are charged, then when we get to 4 p.m. in the daytime, when that PG&E charge raises, we start discharging those batteries to our grid, to the winery, brewery, and food processing plant. So what you see here is this orange line is the load of the building. So that's basically how many kilowatts we're using of energy in the building. And thanks to the batteries and the solar panels, you can see this purple line is basically what we're paying for. This is our grid load here. So this is 0 here, so we're actually producing more energy during the middle of the day, where this purple line drops below this 0 point here, than we're using in the total building. So we are able to ship out to the grid additional energy. So we're putting power out to the university grid. So what this does is by the battery discharge is reducing our total grid load and enabling us to be not energy positive, but almost net zero energy in the entire building. We're certainly energy positive for the winery itself. So if we had additional batteries, we certainly have more energy than we can use in our batteries. So we could add another battery pack and be able to keep ourselves from exporting energy to the grid, because we don't get paid very much for that energy. And it would enable us to further reduce our total grid load and actually someday push the building to be energy positive. But for now, our winery is energy positive. We also want to be water positive and to be able to collect rainwater to use in the winery for processing and cleaning, and to recycle as much of that water as possible. So why do we want to use rainwater? Water's pretty cheap, doesn't cost much. Most wineries pump it out of the ground. Only costs them the energy it costs to use for pumping and storage. Well, again, it gets back to that sustainability issue of aquifer depletion, maintaining your aquifers as healthy as they can be so that you're not worried about being late in the season and running out of water, out of groundwater. It's also, rainwater is about the best quality water that you can find. It has no minerals, no silica to foul the filters. It's just a very high quality of water. So our means to do this is to harvest rainwater, to filter that rainwater through a reverse osmosis filtration system to potable water quality, so drinking water quality, and then to use that water very efficiently for cleaning in the winery through a new clean in place system, and then to take those now dirty cleaning solutions and filter them and reuse them multiple times. And the CIP system enables us to close that loop and to be able to reuse those cleaning solutions multiple times. So, it takes a lot of water to make wine. This is the amount of water it takes to make wine in the winery itself. The industry standard that we typically use is about 6 volumes of water per volume of wine produced. Some wineries are doing much better than that. There are certainly many that are down in the 3 and 4 volumes of water per volume of wine. Our goal is to get to 1 volume of water per volume of wine or less through collection and multiple times of reuse. So how we do that is through rainwater capture. Our watershed is the rooftops of our buildings. So we've got this picture here is our looking down on the RMI South and North here, Sensory Building and the Jackson Building. All those rooftops collect the rainwater. The water never touches the ground. It goes down, it's piped underground out to the backside of the Jackson Building, where it is stored in tanks that you can see behind the Jackson Building. And then we also have non-potable groundwater storage here that's used in the winery and the building for toilet flushing. So we're able to capture 1 million liters of water in a given typical rain season of 15 inches per year here in the Davis area. And that water, that captured water, is more than enough to be able to operate our winery for more than 1 year. We believe that we can operate for two winery years out of the water that we can capture from our wine in our winery.
So Jill, there was a question actually in the chat. Do you add salts to your RO rainwater? And the comment was that pure RO water eats stainless steel.
We have not yet had the opportunity to use that rainwater in stainless steel. The rainwater is stored presently in polyethylene type bags in the rainwater storage tanks. And we are working with civil and environmental engineering to understand the water chemistry and purity, and to ensure that the water is treated at the right levels for both of those. So our rainwater is stored in these large tanks. Each tank is able to store about 45,000 gallons, and then the rainwater is pumped through this reverse osmosis system, very small, low energy system, and gradually we cleanse all of the rainwater, filter all the rain that falls during the winter time, and we fill up the tanks behind the Jackson building with now very pure H2O, just pure, nothing in the water, just pure reverse osmosis water. So then I'm going to hand this over to Dave, who's been working to install a CIP system in the winery.
All right, so thanks, Jill. So just quickly, probably about 5 years ago or so, maybe a little bit more than that, we designed fermenters, 500-gallon fermenters that are compatible with clean in place systems, true clean in place systems. So fixed in place cleaning system with the cleaning solutions piped out to the equipment we want to clean. So we have those in place, and we've just finished the specification for the CIP system. We had planned for it all along, so we have a place to put it. And the goal now is to go out to bid for a clean in place system to use with these tanks and others. And the reason that we want to use the clean in place systems, there are a bunch of them, bunch of reasons why you would use one. The dairy industry and the pharmaceutical industry have been using them for probably 60 and 30 years respectively. They use them because you get better, more reliable cleaning, and that's really important for them in the safety aspects of it. But you also use less water, use less chemicals, certainly a lot less personnel time because you hook up your tank to the CIP system. It's a closed system, you push go and walk away. And it's safer because nobody in the winery is dealing with harsh solutions directly. The clean in place system makes up all the solutions, and you don't send anybody inside the tank to be manually scrubbing. So we're the CIP capable tanks we have, and the clean in place system we're ready to go out to bid for. So that's where we are in that.
So once we have the clean in place system in place, then we want to look at recycling, capturing and recycling all of our now dirty processed water solutions. So the plan would be to filter that water selectively, such that we filter out everything other than the water and the cleaning chemistries, and everything else coming from the tanks, the hardness, the proteins, the sugars are rejected, and just a now cleaned solution is returned back to the winery to be used again and again. And we believe through this system that we can utilize our water multiple times, and it's just more a question of how many times are we able to recycle that water, and that depends on the losses that occur as we go through the filtration systems. So we're really excited about, once we get the CIP system in place, to be able to work once again with our partners Wine Secrets and Suez Water to be able to add a nanofiltration system or a similar filtration system to clean the CIP solutions and recycle them multiple times. So carbon neutrality is important for all industries and all of us. And you know, one of the elements that we are working towards is to be able to capture the carbon dioxide that result from fermentation and to sequester or reuse those this carbon dioxide for other things. Dave?
Oh, I can take it from here. This
Okay,
is Ron. Jill.
Sorry.
Yeah, so one of the aspects of this that we've had in place since we've had the new fermenters, both the teaching capacity fermenters at 500 gallons and all of the research fermenters, is the ability to collect all of the CO2 emitted during fermentation. And this provides, in addition to being able to, in the future, sequester that or to collect that, it allows us to vent all of that CO2 outside of the building. And so that provides some important benefits from the standpoint of worker safety, as well as minimizing any energy usage that would have been required to ventilate the building and any warm air that might have come into the building and the impact on any of the cooling systems. You can go ahead, Jill. So that has been in place for several years now. Now, a next step to that would be able to capture that CO2, and we're working on a couple of approaches to this. In my lab, works on the conversion of CO2 to useful chemicals, but from the standpoint of capturing CO2 from winery fermenters, this is important because it's one of the most pure sources of CO2 that's available. And so we want to capture that in a relatively simple system. We want to be able to recover and reuse this CO2 as one approach. Another approach would be to more permanently fermentation. And versus from fossil fuel conversions or from the ambient air. So along this line, we've created an Aspen model under which we can start to understand and optimize this process. And we're in a stage where we are developing a pilot scale test unit that would be installed in the Jackson building, hopefully as early as the 2021 vintage. You can go ahead. So in addition to being able to capture and both energy and water, we need to think about approaches and technologies by which we can more efficiently use all of this energy and water that we've captured.
Did we lose Ron?
I think so. Give him a second.
Yeah, to come back. Well, meanwhile, there was a question, let's see, about RO and ultrafiltration. Oh. What applications do you see for nanofiltration that's used for separating mono from divalent? So I guess they're looking.
So
just rather, RO, it's clear what that removes versus what ultrafiltration removes. When nanofiltration is, you're really working on the mono versus divalent ion level, and just wondering, is that really necessary? What is that step doing?
So with the correct selection of your cleaning chemistries, you would use a monovalent cleaning chemistry that would be rejected if you were to use reverse osmosis. But as you can see here in this picture, that nanofiltration would allow that monovalent chemistry to go through. If you had a divalent chemistry, it would not pass through the nanofiltration. So by selection of the appropriate chemistries, the nanofiltration can be very selective in allowing both the water and the cleaning solution chemistry to pass through.
Okay. Yeah. So basically, it's just super selective for monovalent to make sure that that's all that goes through. We have a question from another question, and this is probably for Dave or whoever else would like to chip in. How does CIP work to completely replace mechanical scrubbing? Chemical products, stainless steel surface grade, water temperature.
Yeah, so there's 60 or more years of experience in the milk processing industry and 30 in the pharmaceutical industry and probably about 20 now in the brewing industry with this kind of unit. And I would say, there's at least that experience to start from. What they found is that if they use the correct spray devices with something on the order of 2.5 gallons per minute per foot of circumference of tank, if they get enough physical turbulence, physical scrubbing action from the sprays to take off the dirt that they have in those environments. Of course, not only do you need the turbulence, but you need the right temperature and the chemistry for the right amount of time. And so the CIP unit would have to do that. So, off the top of my head, I can't say exactly what's going to work for the wine industry. When we get our unit, that's when it's going to be an active research project to figure it out. But I think it's good news that these other similar industries have been doing this for a really long time and have found ways of automating the cleaning without sending someone in the tank.
Yeah, so basically you probably have to optimize your current cleaning protocol. If you're considering going to CIP, you'll have to optimize it for the CIP unit, if it's possible.
Yeah.
Do you want to skip to Ned?
Yeah, why don't we skip to Ned and allow Ron to discuss his.
Come back.
Yeah, I asked him if he's back, and he said no. His internet keeps cutting out. Was back and then off. So.
Okay.
Oh no, I'm fine if you want to jump ahead to my slide.
Okay.
Great. So I am representing colleagues in food science and technology who are working not just in the wine industry, but broadly in food science and wine, looking at opportunities for valorizing solid waste. As you all know, we have quite a bit of grape pomace that is produced every year. And, sort of the traditional pathways for using this material is, applying it back to the fields, delivering it to animal feed, and hopefully not sending it to a landfill, because that's only costs from an economic sense and environmental sense. And hopefully you can get some value out of it with the alternative pathways. But looking ahead for trying to extract a little bit more value out of this material, we can think about phenolics extraction, including a particular chemical, the anthocyanins, which can be used for food dyes or pigmentation. And recent work from my colleague Daniela Barile looking at oligosaccharides, which can serve as kind of a nutritional prebiotic. So Allison Mitchell has done some work in the department on phenolics, and my colleague Christopher Simmons has looked at extraction of anthocyanins. So all of this is trying to think about, what compounds are of value in the pomace, and then how to extract it in a way that is economically feasible. And then we still have material remaining. So what we want to think about is, how do we extract the highest value product, and then sort of cascade additional processes to get additional compounds if we can, or send it back through the system to extract further value or responsibly treat the waste. One process we've examined is anaerobic digestion. In Dr. Simmons' previous research, he specifically looked at that cascade of extracting anthocyanins and then processing the material through anaerobic digestion. I have another project with Dr. Simmons looking specifically at smaller scale anaerobic digestion systems. In that particular project, we're looking at food wastes, but we are interested in seeing how this technology could pair with processing plants, because it really is more at the scale of a plant or small community rather than what we typically see, which are much larger anaerobic digestion facilities. But the benefit there of anaerobic digestion is the production of biogas, renewable energy that can be either used directly to produce some heat on site or converted to electricity and heat. In our deployment, we are looking at installing a combined heat and power unit that would deliver both renewable energy sources to the local users. Finally, anaerobic digestion doesn't just produce the energy, you also have this nutrient-rich digestate that is left, and that can then be circled back to agriculture, and therefore really sort of close the loop in this organic material system to try to get the most value out of this material. Finally, there is one additional pathway I want to mention from Dr. Simmons again, where he's looking at biosolarization. So this is actually applying this material onto fields, covering the field with a tarp, and then saturating the soil with water. And you can get basically an anaerobic digestion process going on within the soil, and having the temperature and microbes sort of take over the soil and reduce the need for using fumigants. And so he's looking at that in some orchard crops now, but it's really sort of an interesting approach to leveraging, again, sort of a waste product and putting it to use, and really supplanting the use of some nasty chemicals in agriculture. So this slide is a little bit busy, but it kind of shows the potential, or how we think about how we would treat and really utilize waste in a new way from a systems perspective. And this is a way we approach a lot of issues in the food sector and looking at agricultural byproducts. So thank you very much.
Well, thanks, Ned.
So Ron's back in audio. Are you there, Ron?
Yeah, I'm here.
Okay, Ron, see how it goes without your video on, if that helps at all.
Okay, yeah, I called in on my phone this time as well, so
Okay.
hopefully
Much
that will work a
better.
little bit better. So one of the technologies or process operations that has been an important target for us is looking at cold stabilization, which is one of the more energy intensive steps. And so a number of you might be familiar with this type of operation, where we're trying to replicate the traditional cold stabilization approach, which is using at least crystals of potassium bitartrate. And instead of adding this into a tank, we're adding this into a column. And in this column, we can fluidize these crystals, and they can grow while they're removing potassium bitartrate from any wine. And all of the potassium bitartrate stays within that column. It also enables us to utilize heat exchangers so that the wine is returned into the same tank at near cellar temperature, which also then provides a benefit of water usage, or minimizing water usage that would have subsequently been used to clean any of the tartrates on the walls, as well as any of the cleaning chemistry. And so we have moved this approach beyond the bench scale, and we now have a pilot scale test unit that's operating periodically in the teaching and research winery. Maybe Jill, you can start that video.
Yep.
It's just very short, and under which we are starting to fluidize that bed of potassium bitartrate crystals. So it eventually would expand to a much greater degree than that. And this, of course, can be scaled by having multiple columns with a goal of being able to treat, for instance, a 20,000 gallon tank in about 10 hours.
With a much smaller volume of wine chilled at any given time.
Exactly, yeah. Pretty much the only wine that is chilled is the wine that's inside the column at any given time. And I think that's all that I had. I'll hand it back over to you to cover the other technologies under consideration.
Great, thanks, Ron. So we, of course, also need hot water and cold water in the winery, and so once we've captured our rainwater, cleaned it through an RO system, we want to be able to heat that water or chill that water as our needs exist in the winery. So we're looking for ways to do that are very low energy or using renewable energy. And so we've identified a partner, Ergsol, interesting company right down in Fairfield, that produces these really beautiful solar heat pipes that are excellent at capturing the sun's heat energy and and what they do is we have a copper pipe that is basically a heat exchanger up at the top of the tube, and cool water flows into this heat exchanger, and the heat from the sun's energy causes a working fluid, often methanol, to go into a gaseous phase. Hot gas comes up into this heat exchanger area. Water is flowed across the heat exchanger, not through this bulb, but in next to that in direct contact, such that the copper conducts the heat, and the water is heated as it moves through this heat exchanger area. So we can, using these roof-mounted panels, we can heat enough water for use in the winery, storing it in a well-insulated tank, so that we would have water at the 50 C or 120 Fahrenheit type temperature that we think we need in the winery. We're also looking for technologies to chill water, so that we would have chilled water for fermentation control. Still looking for appropriate partner and appropriate technology for that, but ultimately we're looking at solar-powered ice machines or adsorption technologies that would provide chilling, a chamber with either ice or a cold chamber, where we could run water that has been warmed from use in the fermentation tanks or other places in the winery through a chiller, and then back again into the winery for use for fermentation control. Still looking for technology for that, so if anyone in the audience knows of possible technologies, we'd be very interested to discuss that with you. Okay, so let me get back on track here. I think, Dave, we're to your closing scorecard here.
Just to kind of summarize where we are, the three goals that we had were to be energy positive for the winery, to be water positive, and carbon neutral. So in terms of the energy positive, we're pretty much there for the winery at this point with the battery power and solar power and so forth. For water positive, I would say we're probably about 70% of the way there, and hopefully in the next year or so we can be almost all the way there. And in terms of getting to carbon neutrality and capturing our carbon dioxide, taking out of the environment long term, I would say probably 20 to 30% of the way there, and a bunch more at the research stage with Ron's group and others. So that's great. And what you might have noticed is, in addition to these three goals, we've done a bunch of work on other things for sustainability. So the ideas that we had led to other ideas. And so we've got a lot of new kind of sustainable ideas that Ned talked about and Ron talked about for valorizing waste and for reducing energy. And so I think with that, I just want to thank everybody for your attention. As one of the normal hosts of this show, I would say this is about the time when I usually tell you what next week's program is. So I'm going to do that quickly, and then we'll go back to asking questions. If you have questions that you'd like to ask any of us on sustainability, you can start to think about them or put them in chat. Meanwhile, next week we're going to have Professor Beth Forrestal as our guest. She's a relatively new faculty member. She started officially in the fall. She works on the effect of heat spikes in the vineyard and the effects of climate change and how to adapt to climate change.
It's going to be Beth, Lauren Parker, and then one of Beth's graduate students, Martina Galliano. So it's three.
There you go. So you got three for the price of one next week. And so that's next week's show, next Tuesday at 2 o'clock. So with that, I would like to say that, if people have more ideas for us or key issues they really want us to work on in sustainability, this is a good time to put those forward. If you have questions, please ask questions. I will say there's a couple more people on the line who have actually contributed, been part of our team, and some of the things that you heard about. Saw Bob Pullman was on the line from Treasury, and Chick Brenneman from our winery, who was instrumental in helping to build the Jackson building and the winery and a lot of the sustainable features in that. So with that, I'll open it up for questions. You can raise your hand electronically in the participants panel, or type something in chat, or just unmute and ask a question.
I'm going to start off a quick question and to give people time to think about this. So, Joel, my question is directed at you. You mentioned, things that a winery can do, or what our winery is doing to be electricity neutral or positive. However, I'm thinking about what can other wineries do, because we know we're in the real situation of fire season coming up and coinciding with harvest. If PG&E cuts power due to high wind conditions, what is things that the average winery can try and do to prepare for this? And when it happens, what can they do?
Sure. Well, I think one thing first that many wineries have found out the hard way is that, many wineries have solar panels with the understanding that it's okay if PG&E cuts my power, I still have my solar panels. Not the case. When the power goes off, when PG&E cuts your power, unless you have a very special configuration, the solar energy is also going to be shut down, done for protection of emergency responders. So what you really need to have is, in addition to solar panels, you need an alternative source of energy. Certainly, we would prefer that you used something like battery banks, multiple different versions of batteries that you could employ and have, as long as your system, your electrical system is set up so that only your most important electrical loads, only for chilling and running a few small pumps, could get you through the harvest season and keep your wines at a reasonable temperature, enable you to continue to perform harvest operations. Alternatively, gas-driven generators are also simpler to enact, and you would most likely need a fairly large generator to operate your winery. So there's items like that you can employ, but of course that takes planning for modification of your electrical panels and ability to employ temporary measures such as a generator, or have a system like batteries in place.
Okay.
So if I can maybe add something to that, Anita, I think if everybody wanted to go away and do one thing that's going to help them, that's, I think, doable, not simple, but doable. Most wineries don't know exactly how much energy they're using and what their peak loads are, or how much water they're using, and actually doing something to putting meters on the right parts of your electrical, putting just simple, inexpensive flow meters on your hose bibs, knowing how much water and energy you're using is one of the first steps in trying to be more efficient. It's hard to know how to replace what you're doing if you don't know what you have in the first place. So I think that's something that people can do that'd be somewhat straightforward.
And I think that's a natural segue into, okay, now you know how much energy and water you're using. Are there things that wineries can do to reduce the amount of energy and water they're using without fancy new equipment, right? Redesigning their winery. I mean, everyday things?
Well, I think, like Dave said, the number one situation is to measure and to understand what your loads are, and it's not until you do that that you find those surprises. Where are the inefficiencies? For example, once we metered our winery, we discovered that our hot water pressurized water cleaning jet system just doubled the entire winery electrical load just when we were operating that one single system. I thought there was something wrong with the winery electrical power system. The load was so high. So it's a case of, like Dave said, measuring what your energy use is, what your water use is, and look for those escapes. Look for a water circuit that is much that shows a flow that's much greater than you had expected. You probably have a leak or other such situations. Thanks, Anita.
So, and I would add to that, you know, one of the things that Jill mentioned before when she was talking about loads is that many times the price of your electricity is determined by your peak load during a certain time period. And so if you find out that your high pressure washer is spiking your demand, you know, it's twice what it normally would be, just actually moving that cleaning from that afternoon period to the morning is a way of potentially not decreasing your overall usage, but your overall cost. Similarly, part of this, without replacing any equipment at all, is training. So if you're thinking about water use is almost all from cleaning. I've seen people on our crush pad who use a hose to get the grape skins to go down the drain. And I've seen, you know, many times a student standing out there with the hose, one skin left, 20 gallons of water from that hose, and the skin jumps over the drain to the other side. And another 20 gallons and jumps over back the other way, instead of just bending down and picking up the skin. And so part of this actually can be solved with training. And I think good training is one way of reducing your water usage. And it's going to help. We found it helps. Chick found when he was winemaker to actually have those meters on the hoses. So it makes it more of a game or competition. How much can we reduce our water use by just doing simple things like that?
Sure, and obviously if you know where your major energy and water use is, you can make it more efficient. And then if you're in the position where you are looking at new equipment or redesigning something, then you also know where you can focus to buy something that is more energy or water efficient or allow you to be. So Clark has an interesting statement here, which I'm going to read. And
Ned has to leave at 3, so I don't know if we have any questions.
Do we want to answer that by chat?
I'm just saying, I don't know if we have any questions specific, if anyone has one specific for Ned before he runs. So
okay.
Or
Anybody
if
have a question?
Go
if
ahead.
anyone thinks of something later, you're welcome to email me. I'd be happy to connect with anyone here. So, but you can take a moment and see if there's a question right now.
Doesn't seem like.
All right. Well, then feel free to reach out over email. Thanks, everyone. It was nice to chat with you today.
Thank you. And if anybody has questions for any of the speakers, you feel free to contact Karen or myself.
Yep.
And we will make sure that the speakers get the questions and hopefully get back to you in a timely fashion.
Yep.
I would like to thank all the speakers. Clark, if you hang on, we will answer your question or statement. But I would want to thank everybody else that needs to run because it is 3 o'clock. Thank you for joining us today, and we hope to see you next week. Thank you. Jill, can you see the chat?
I don't have that up right now.
Okay, I will read it out loud. In principle, a heat pump or glycol chiller produces both hot water and cold water. Usually, evaporative cooling is utilized to carry away the waste heat, but it should be possible to capture that energy to reheat water or other energy capture designs, such as electricity generation via steam turbine.
Do you want me to take a stab?
Yeah.
So maybe I'll give a general answer. I don't know if Ron or Jill have more specific answers. You know, the whole idea of what's called heat integration in chemical engineering is the idea, and this is used, you know, to the nth degree in a refinery. You never take a really hot stream and just let it cool down naturally, and you never take a really cold stream and just let it warm up naturally. You're always looking, where's another stream in that same facility that can be used with a heat exchanger, a well-placed heat exchanger, to recover either the heating or the refrigeration. And that's an idea that really hasn't been, I think we haven't taken advantage of that idea as much as we could in the wine industry. I think there's some examples of that. But just as an example, you know, what Ron showed with the cold stabilization, that's a perfect example. Even if you're going to use a traditional cold stabilization approach where you chill down your tank, you let the tartrate crystals settle out, and you rack off of them. That's a lot of refrigeration in that wine. You could actually use that to chill down the next wine that you want to cold stabilize, instead of letting that stream just warm up naturally after you rack it off and using a huge amount of refrigeration to bring the next tank down to temperature. So and that's a kind of a general answer, but I think this idea of heat integration is one that we haven't explored enough in the wine industry.
That's exactly correct. One of Ned's colleagues in food science, Chris Simmons, has done a lot of work in vegetable processing plants with heat exchange and efficient use of heat in vegetable processing. So yeah, it's just a case where the wine industry has not typically had those integrated systems to be able to utilize heat and or cold, however you want to look at that, in multiple different ways.
One thing I'll also mention from, I think this is a second comment from Clark, probably about 4 years ago, maybe, Jill, after I saw some of the students using huge amounts of water to get skins down the drain, we did go to the mechanical engineering department, and we had a really good senior design group work on basically, I think it'd be something like a cross between a Zamboni and a Roomba, basically a robotic crush pad cleaner. And this thing was meant to go around autonomously, spray just a minimal amount of water with a sweeping device. And basically it was I guess a street cleaner, autonomous street cleaner. And they got pretty far. They didn't quite finish, but they got pretty far. And something like that, certainly, you know, the company decided to commercialize something like that, I could see it saving both personnel costs and water and cleaning agent costs.
Especially for, I would say, larger surface areas for your larger wineries, they might be really useful, I would say. But yeah, it was pretty cool watching that thing go around.
They made it out of very solid metal supports, and the thing must have weighed, I don't know what, with the batteries that were on it, hundreds of pounds.
300 or 400 pounds.
It was actually a little scary.
You did not want that thing to hit you, that's for sure. Anyway, I think that's all for our questions. I don't see any new questions, and it is 3:05. Thank you very much for everybody. Thank you for the speakers. Thank you for everybody that's still online and attended today's sessions, and we'll see you next week. Thank you. Goodbye.
Thank you.
Thanks, everyone. Bye-bye.